me get to
Stack left.
You could not.
Like, dang, she's back and it's already giving me
Make fun of my picture.
Okay, hold on. Yeah, that's what it's done. How's the day going?
It's going fine. Thank you. Okay, what are your questions? 18?
Two, okay? You keep rolling over.
Okay,
I'll tell you right now.
thank you. Let's get started here. I'm going to go ahead and copy this one over. It's going to give me more space to work with, so let me go over to where to go. Okay, so just by looking at this, you should be able to recognize that this is going to be a perfect square, right? So it's just a binomial times itself twice.
Yes.
So if you remember the rules that I gave you, that means that you're going to end up with the first one, which is the quantity 4a plus b squared. And then you're going to get 2 times the first and the second one. So let me slide this over a little bit so I can get my space in here. So this should be negative 3, 4ab plus b. And finally you should get the negative 3 squared. Okay, so there's your setup.
What the heck?
Okay. Any questions on how I set up this problem to solve? All right, let's finish this up.
So what if it was double parentheses instead of brackets? Would that make a difference?
No. Sometimes, like calculators, all they can do is do parentheses. They can't do brackets, but usually when we're doing math and the order operations, what you'll see as they start to get more complex, they'll start with parentheses, they'll go to brackets, and they'll go to braces. After braces, they'll repeat the process. They'll go parentheses again, brackets, and then braces again. So that way you can see a clear progression on how to move outward. Okay? So let's... Well, it's a perfect square, right? Remember I said that middle one happens twice? So that's why you take this times this number and you doubled it. Okay, we talked about that yesterday. Yeah? No, I'm doing this right now. Is it on this? Oh, at the very top, there should be a little pop-ups. The menu should already be there. No? Where are you at? Oh, you're on the ugly bar right here. Go to use Chrome. I don't like this one. Alright, yeah. Chrome should be better. At the very top, once it does that, you'll see a little strip, and it'll say, click here for something. Okay? Alright, so I'm going to continue. Let me close this email. Oh, come on. Anyways, so we're good here?
Sir.
I'm going to continue. I'm going to have to square this, just like I kind of did with the original problem. So I'm going to get 4a squared plus 2 times 4ab, and I went ahead and multiplied those two, plus b squared. This becomes minus 6 times 4ab plus b. 4ab plus b.
Yeah, that's what I was going to ask you.
Thank you. I jumped the gun. It's 4a plus b. It's the middle one. Look where'd that come from. Thank you. Should fix it here too. 4a plus b. And then finally I'm going to get plus, what's 3 to the second? 9, right? Okay, let's clean it up. 4a squared will give me 16a squared. 2 times 4ab will give me a positive 8ab. B squared will stay the same way. And then here I'm going to use my distributive property. So that'll be negative 24a minus 6b plus 9. Are there any like terms?
Nope.
So then we're done. And you would actually punch in all of that just the way it is into your solution block. Yeah? Uh-huh. Let's get everybody a minute to copy that down.
Why is it 4A and B together?
Now, well, give me a second. For A and B.
4A plus.
This is one way that I would do it. Doesn't necessarily mean that's the way you have to do it. But I know some things. And I'm going to have you work through them right now so that you can figure them out. And you know what I know. Okay? Everyone done copying this? Okay, laptop should really be closed at this point. You should be taking the notes and not doing your homework. If you're trying to do your homework at the same time, you're missing out on one or the other one. Right? Gracious. Gracious, gracious. 5.4?
Yeah.
You.
Yeah.
Paybacks, right?
For what?
Karma.
For what?
I know.
Should have.
Yeah, Cambria should have.
Okay, moving on. 7? Did I hear 7 or 8?
7.
My favorite number. Oh, it's to find the product. So, let me copy that over. Did I close the little, there it is. Snapshot. I think you do remember how to multiply. So, let's do this. What is 8 times 9?
72.
So this is a positive 72. What is 8 times the negative 2x? Negative 16x. What is 8 times x squared? 8x squared. Okay, so we're done with the 8, right? Now we got to do the x. So what am I going to put in this position here? A 0. Okay, don't do the x's anymore. Okay, if you're one of those people that used to put x's in those spots, don't do it. Because it's going to look like a variable. It's going to mess you up. Now, what's x times 9?
9x.
It's a positive 9x. What's x times 2x? Negative, yeah, thank you. I said 2, didn't I? That would be negative 2x. What's x times x squared? X cubed, or x to the third. So now you're just going to add them up, or combine the like terms. That's a positive 6. That's a horrible 6. That's better. 6x squared minus 7x plus 72. Okay, so it's just like before. Please don't forget those models, because tomorrow we're going to do division, and you need to know how to divide the old school way. Okay? You don't remember how to divide? Well, we'll see. You'll learn it. Yeah, you can't use your calculator for this one. Yeah, the 90s called. The Paisa's called from the 90s. Buy yourself a what? What? I'm gonna put these up here. Any questions on anything else? 70? We didn't do 70.
No,
1, 7, 17? how do you do this one using mental math?
Oh, God.
4,000 times 4,000?
4,000 times 4,000. Is that going to be it exactly though?
Yeah.
Subtract what? 1?
Could you use 4,000 times 4,000?
Well, if you look at this, it's going to be.
Because could you take?
Well, here you're adding another 4,000 here, right?
Yeah.
Sorry, not really 4,000. You're adding another 300 or 3,999, but you're also adding one here. So I think that might just be 16.
I just want to check.
Oh, plus the 1, and then here's minus 1. Well, you're rounding off is what you're doing here. So you're taking away a 399.
It's 15,900,900.
I'm just saying.
15,900,900.
3 more nines. Oh,
No, not like that. I mean, you know what I mean. Like,
I don't know. I wouldn't make you do that in your head.
Just calculate it.
Here's what they're doing. If you were to round this, you're going to get 4,000 times 4,000, right? But here we're actually adding. Oh, sorry. And the top one, referring to this one, we're actually taking away. We're taking away a 3,999.
oh, I see.
We're taking that away once. Okay? But here, we're also adding, what are we adding? 1 to this?
Yeah.
So we're adding 1 to this. So if you do the 16, 1, 2, 3, 1, 2, 3, and you take away one of those, it's actually not that, it's just 1, isn't it? Oh, that's the deal. My bad. Hold on. So here what we're going to do to fix this is we're going to take 1 away. And then here we're going to add 1. So that would give us the 16,000, right? And then what we need to do is we need to take away 1. So if you take 1 away, because we added 1, so we take it away, you're going to end up with. Because once you put 1 back in, it jumps back up to 16 million.
So that's it?
Yeah. Do I try it again? What'd you there?
Just have to like put it in a calculator.
Yeah, I would just do it in a calculator. I wouldn't. But you have to be able to do that mental math, right? So this should be 1 with. But then you're going to take 1 away, which is going to convert this into a 9. 1, 2, 3, 4, 5. Mental math. This type of math will make you mental.
Yes.
Did you do it in the calculator too?
Those came out too.
Do 25. Ah! Okay, ready? What does it mean when 2 variables are next to each other? Multiply. So we're going to take f times g. Now, we're actually going to find f times g of 7. So what's the x becoming? So what's 7 squared? 49. Take 10 away? 39. So f is really just 39. And what's 3 times 7? 21. So what's 39 times 21? Math.
Wait, really?
Okay, what is it? Oh, do mental math. What? What happened?
Oh yeah, do mental math.
7 times 7 is 49, but you take away 10. So that's 39.
Plus 1 to 39 and minus 11.
Little too much.
How do you do that?
Control plus?
Plus also minus.
So just no, instead of spot.
That was good. That was good. Alright. Other questions on the homework? 27. Okay. Again, we're doing f times h of -1/4. A -1/4 times a -1/4 is going to give me a positive 16th. Minus 7 will give me 6 and 15/16 negative. And I'm going to multiply that by whatever the value of h is going to be, which would be -4 1/4. So multiply those two. Math. And no, I'm not going to do the fractions for you. If you're having trouble with fractions, you need to come get yourself tutoring. Yes, sir?
I was stretching.
I guess I
Stretching is always fun.
I just get
Yes. Don't be lazy.
lazy.
Don't be lazy.
When you got yardsticks for legs, it sucks.
Are we done? All right, cool beans.
Find the GM.
The GFC. The GCF. The Golden State Foods. GSF.
GCF.
Okay. Ready? Ready now? Find this for me, please.
You did it a funny way.
Not a funny way, it was a great way.
You did it a great way.
It was the bestest way ever.
Can you teach me to do that?
I can teach you how to Dougie. Oh, you already have it. Very nice. That's nice. Amazon?
Mr. Munoz.
It's called an earwig. A song stuck in your head is called an earwig. What? Who's calling me?
Me and Cambria were here to take session. Can we take it at the end of class or do we make it?
How'd you score you? I have a couple of people that are going to stay after school to do that. Jessica. You already have it?
No,
Did you start with this?
I don't know what that is.
What's in it here? You see what I'm doing? 1, 1, 1, 1. What's 1 plus 1? So what goes here?
Yeah, I took 2.
Here?
Oh.
So we're gonna learn that?
Looks like Gallagher.
Yes.
Mr. Munoz, can I come in like during lunch or something?
35, 41, 7.
I got you. Oh,
I got it. I get it. I get it.
oh, I get it. I get what you did.
Ah, come back.
You can do it.
You started to look like Miss Myers.
Oh no, you didn't. You just call me feminine.
No, she couldn't work the board.
Oh, because it's not calibrated.
It's not
That's Venus.
Yeah.
so. You're gonna take a pen? Okay.
Yeah, I know, but isn't it?
Pen. He was holding his pen. And I was like, you're gonna take a pen? I just figured this kind of awkward.
You're missing a 5.
What am I missing?
You're missing, you need to, erase that without.
Yeah, but. Oh! That's why these are wrong.
There you go. Miss Munoz messed up.
Yeah, I was like, why is it not making sense here?
Okay. You put that one there, that one needs to
Oh, I
go
have
here.
it.
Yeah, that one needs to go there.
This needs to be a 2.
Yeah. There we go.
That's all. That's good. We don't need it. Let me fix this.
Going Ghostbusters.
Mr. Munoz.
No. I'm not going to teach you. Okay, where's my calculator? I was messing with all of them.
Whoa, wait. I'm gonna go out. Yeah, I'm gonna get lost. I got the whole pyramid thing. I don't get the pyramid thing either.
What?
I got the pyramid. I don't get it.
Somebody help out Chase. She needs to get the pyramid part.
Yeah, I don't understand the pyramid. I recognize
Segments close to equal power.
it's like a like it.
I got like the outside.
Ah.
I was like, they're part of my house either way.
I was oh my god. You know I did the pyramid, but how do you write that into this equation? I don't get how you use the pyramid equation. That's what I don't get. Huh? Oh, that's how I get. Like I can see that pattern, but I just don't see the. I just write it down.
You see me do that matrix?
What?
Cars,
It's the pyramid.
What is the pyramid? Okay. I'm not entirely sure, but I know how to use it. Does that make sense? Okay, well, basically all that pyramid is, see how if you go diagonally, it goes 1, 2, 3, 4, 5, 6, 7.
Oh, I see it now.
So if you look at that fourth row down where it's like,
Yay!
I think I see it.
I see it.
it leaks down and that's a 6. Then the 4 plus the 6 equals 10.
The 35.
6 equals 10. See it? And that's how the pyramid works.
I see it. Who's gonna
I know you see
We're
it.
talking about to like play pool. Like game pitches. Yeah.
But I have about don't know when you're right. Are you adding more alcohol in your drink?
I'm working on it.
There you go. There's all of it.
Now, can you teach me because I don't know?
No, I will not teach you. What you need to do is you need to study this. Math is about patterns. Okay? So, did everybody figure out the triangle pattern at the top?
Yeah.
Who has not? Someone explain it to the triangle to him. Okay, can someone come up here and explain the triangle? How does that work?
Okay, so
Let me take this real quick, Cal. Actually, you know what? Build it again for them.
build
Here.
it again.
Go. It's easier to do that.
Okay.
Okay, you want to tell them how they get that?
Yes, these are ones. Are there 2 2s here?
There's only one.
Remember, it's all about the patterns.
Right.
Okay, you want to tell them where you got the 2 from?
Okay, so where I got the 2 from is these 2 ones here. If you add them, it makes 2. Then, if you add these 2 guys here, you get a 3. If you add these 2, you get a 3.
You subtract, you get 1.
Don't confuse me.
Well, because no, seriously, we're gonna start get the ones on the outside too.
No, you always just start with 1.
Oh, okay.
Then if you go for the next tier, it's going to be 4. See the 1 and the 3 makes 4. Same over here. But now you have that empty space in the middle, so you add the 2 3s. Making 6. And then you just keep going down. So then this is going to be 5.
And then 5.
10, 10.
Yep, then it's 10, 10. And it just keeps going.
Why 2 10? Oh, never mind.
Because 4 and
You see
6,
it?
4 and 6.
Okay, this is called Pascal's triangle. This was found by Blaise Pascal, one of our old mathematicians. And it turns out that Pascal's triangle is awesome for multiplying binomials. Not just that, but you can actually even do probabilities with it. And once you guys get to a section on doing probabilities, you'll figure out how to do that as well, which is really very cool. So combinations, permutations, who would have known? Also comes out of Pascal's triangle. But now that you know how the triangle works, why do I care? Why does it even matter, right?
It tells you how many terms and how many.
So I guess the question is, how do I know where to stop my triangle?
Whatever the number is on top. Yeah.
The exponent is the row you use. How many? The number on the left has to correspond with the exponent.
Okay.
So in this case, it's 7.
So, how do I know which one to use? Okay. If you take a look at this diagonal, it will tell you what power the binomial needs to be to. So if I was going to do a 4th degree, then I would use this row right here. Okay? Now, if that's a 4 degree, 3 degree, 2 degree, 1 degree, what's the top one? 0 degree. Now, doesn't that make sense? What did we say anything to the 0 power was? 1. See how there's just a 1 at the top?
Yeah.
Oh, ah,
I didn't get that one.
cool, right?
That is like 9.
No, that's math. Blaise Pascal. So, in spirit, he's alive in my heart. So, now that I know I have to use this row, what are those numbers? Why are those numbers important to me? They have a special name. We talked about the
Are
name.
those the powers?
Not the powers. The name starts with a C.
Components.
Not components.
Coefficients.
The coefficients. They're the coefficients. And I'll kind of highlight them. See the 7? 21. 35. 35. 21. 7. Go ahead and ask me. But Mr. Munoz, what happened to the 1?
They're there.
Do you need to multiply it by a 1? That's why I leave them out. So there's a 1 and there's a 1. Okay? No, you don't. You shouldn't feel stupid. It's when you look at it and try to take it all in, it's difficult. And that's why I said you have to stop. And here's the idea behind it. A lot of people, and it's not your fault. Thank you for being quiet. You're so kind. You kind of get programmed to think math is hard. Math is not meant to be hard. It's supposed to be all about puzzles. And if you have the mentality that something's hard and you're not going to do it, guess what's going to happen?
You're not gonna do it.
You're not going to do it. Okay? But if you approach it from a different way, talking about, oh, this kind of looks like a puzzle, and I like puzzles, right? Who doesn't like a little puzzle? All the answers are up there. It's just a matter of figuring out what the pattern is. Okay? So here, I've given you the coefficients. Where'd all the other numbers come from? Someone besides Ash.
Wait, say that again?
I've already shown you where all the coefficients are. There's the 1, 7, 21, 35, 35, 21, 7, 1. Where did everything else come from, right?
The triangle.
They don't. That's all I need the triangle for. Jess?
They're part of the original equation or expression.
They are, right? How?
Well, the original one was 2x plus 5 to the 7th. They're all 2s and 5s.
Well, yeah, so in here, notice I have 2x, but I don't have a 5, so maybe we'll have to think about that. There's a 2x, there's a 5. There's a 2x, there's a 5. There's a 2x and a 5. 2x and a 5. You guys see that in there?
And you wouldn't cross the whole line.
But over here, there's no 2x.
Is it?
So is it the 2x and 5 from inside?
Yes.
What's that special rule in there? Why doesn't the first one have a 5 then?
It's at the end. It's in
Oh,
the order of the
The commutative
Because
properties.
Okay.
Because that last number you're gonna multiply 5 7 times, and there's no term in that.
There's no what?
There's no term in that 5, so you're gonna get an X.
Commutative properties.
Ashley?
Okay, so at the beginning and at the end, as you can see, the power is for the 7 for the 2x at the beginning, right? That makes the power for the 5 simply a 0. So it doesn't exist, it's not there. So there's no point in writing it. And then he did the same thing at the end, except it's the reverse, because as you can see, as you go down the line, the exponents also go down or go up, depending on which number.
You cycled through all the numbers on that line.
Chase, did that make sense?
Can I go up there?
It did?
I get it. Like
Did you like?
I
Can
understand
I
what
go
you're
up
saying,
there
but
and
I
then
get
you
it. Like I
Cambria. Does that make sense?
I was just joking. Yeah, the top bit.
So tell me, no, we were talking about the bottom part.
I'm trying to figure that out.
I got what you laid down.
Callista?
Which bottom part?
Not like
What part didn't you get?
most, like it's mostly the bottom part.
Well, she just said, so you can ask her.
You guys want me to show you?
She said it.
Yeah, I can't
Okay.
do
Yeah,
it
it's
when you tell me.
it's the powers. They're going down.
Like,
But the 2x is probably going down.
Because the first
Yeah,
term
exactly.
is 1. The
Hold on,
second term.
just one at a time. Have a seat. People need to learn to listen. Okay? And here's the other thing too. You shouldn't just be listening when I'm talking. Because some of you guys got good stuff to say, and I shouldn't be repeating that. You guys should be listening to them as well. And if you miss out, that's on you. Russell, you got that? Bottom part, how it works?
Aw, he's so nice.
You want to ask Ashley?
Ask her.
That was a rhetorical question, I think, or maybe a prompt.
Well, whenever you say ask somebody, you made us ask them.
Yeah, so do it. No, just explain to him so you can
Just
listen.
explain it. Okay, so at the very beginning, you see how the 2x is raised to the 7th? The very beginning of the problem? Now, if you look down the problem, that 2x, the exponent keeps going down 1, right? So basically, that 5 is there, but it's raised to the 0 power on that first part. At the end, it's the same thing, except it's the 2x that's raised to the 0
Yes.
power.
Finally got it.
This might make more sense. What was it? 2x plus 5 to the 7th? And what were our coefficients?
The coefficient.
Let's start with the coefficients. You guys ready?
Yeah.
1, parenthesis, plus 7, parenthesis. Give me a second. Let me make these smaller because it's not going to fit here. So 1, parenthesis, plus 7, parenthesis, plus
21.
parenthesis, plus 35, parenthesis, 35, parenthesis, plus, I'm going to go here, okay? 21, sorry, yeah, parenthesis, plus 7, parenthesis, give me space, hold on, plus 1, parenthesis. Did I ever see this pattern?
I saw that pattern.
I get it.
Everyone's okay with this one, right?
Yes.
Okay,
Sir.
this is the first term. I don't care what it is. I'm going to call it F. F, 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 F. Right? What goes in the other parentheses? The other term, which is a positive 5. I'm going to call it S. S, 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 S. We're good?
Yep.
Now, here's what happens. When we look at the exponents to those parentheses, for the first one, we're going to start with the highest degree, which is 7. Then it goes 6, 5,
0, 1, 2,
with the S's, we're going to start with,
0, 1,
whoops, where? What was I aiming for?
1, 2, 3, 4, 5, 6, 7.
Notice what the degree of every term adds up to.
It's a huge
It's always 7. Now, here's why you didn't see a couple different things going on. Do I need it? Did I need the 1?
No,
Well, why would I need this one?
because it's just
Isn't that also a 1?
yeah.
That's why you only saw
F.
2x to the 7th power. And then you follow the pattern. And then do I need this one? Do I need this one? And that's how you do a binomial expansion.
Wait, can you try to?
But wouldn't that F, the last one, be 2x?
Well, if it's to the 0 power, it's just 1. 1 times 1 is 1.
Please tell me.
And then you'll have whatever that number is to the 7th.
Please tell me you're recording this first time.
No, I'm recording it right now.
Oh, you are? Okay.
I'm recording this right now.
That's cool.
Okay? So, you can take any problem that's a binomial, write out your pattern, plug in the values, and expand it without having to go this times this times this times this. Do you know the old method?
Yeah.
You can just do it this way.
No, never mind. That's too much.
I have a question for you, and I just thought of it right now. For everybody.
Yeah.
Will that work?
No.
Multiplying numbers by themselves? Just numbers?
Because I did that and I did not get anywhere close.
So if I wanted to do like 23 squared, would that work?
Yeah.
Or if I did 23 to the 7th, would it work?
Is it because it's not them?
What?
Are you talking about like if it's just 23 to like something?
Wait, would it work or do you have to have two?
What does it be? Is it?
That's what I'm asking. The question just came to me right now. I didn't even have this plan, but I'm saying, It's there. It's there. So, oh yeah, it's also YouTube. Subscribe and leave your likes and a comment down below. Don't change it.
Go. It's on YouTube. It's on YouTube.
I can wait. I'm not doing anything. I'm just standing there. You guys are harassing me.
If you were to do an old school, would it be like I like?
You're gonna have like a couple of pages of work, and you might have to write on your paper diagonal, because that polynomial is gonna get the polynomial is gonna get really long.
I'm be honest, but I do feel lost.
Do what?
I feel very lost with this.
I found you. You're right there. We'll do another one after this number one because I want to answer that question. Actually, you know what? I don't usually do this. Nah, it'll just be good discussion. Yeah, we're gonna do it. Calm down. So we're gonna do it. So if I did 23 to the third, I'm gonna use my shortcut here. 23 to the third. That's supposed to be 121/67. It's supposed to be that.
Okay.
Now the question is, will this binomial expansion work?
Yes, because it's a minor.
How would you do it?
1 times 23.
So this is a third degree, right?
Yes.
What were those numbers? 1, 1, 1, 1, 2, 1, 1, 3, 3. So it should be 1 something something plus 3 something something plus 3 something something plus 1 something something. This should be 3, 0, 2, 1, 1, 2, 0, 3. So what goes inside of that?
It'd be 23.
That is the question.
23 and 0.
Would it be 23 and 0?
23.
Not 23 and 0.
23 and 1.
Not 23 and 1.
1 and 1.
How were these? How was this binomial separated?
By the plus sign.
By what? No. Well, what is
It's a binomial. The parentheses. It was a binomial.
what is this?
Parentheses.
This is just just because you say it louder doesn't make it right. That's funny. You sound like a teacher, you know, like when you just say something and they don't understand and they're like, I don't get it, so they say it louder, like you're gonna get it. Like no, just because you say it louder doesn't make it right. These are broken up by place value, right? That's x to the first power. What is this? X to the
Number.
some number, yes. 0 power, right? So we need to take, in order for this to work, where to go?
Oh, okay.
This has to be broken up into its place value, which is 20 plus 3. Okay? Now, hold on. I do want to point this out. Yeah, 20, the 10s and the 1s, right? I want to point this out. I've never done this. So I'm just going out on a limb.
Nice.
I'm using the math rules, right, that I know. And I'm hoping that this will be right, because then I can just say math. So, 23, 23, 23, 23, right? So, let's see here. Go ahead.
What made you choose 23? It could be any number.
No, I can't, because 23 is saying I've got 2 sets of 10 and 3 sets of 1s. It's place value,
Oh, okay.
right? So if I had, well, actually I couldn't do a 3-digit number because it's binomial expansion. Okay, so let's see here. 20 to the third. How much? That's not 60. Oh, you're just joking. That is 8,000 already. Woo, that's scary.
Not really.
Okay,
Yeah,
because it's 12,000 we got to get to. That's already 8 of it. All right. Oh, that's okay. So let's go. This is 3 times 3, right?
Yes.
Which is 9.
Yep.
So I'm going to do 9 times 20 to the second.
3,600.
That's 3,600.
We're at 12,000.
This is, how much is that?
wait.
That's 9 times 27 times 20.
That's 11,000.
That's 11,000. Let's finish this up.
I
So
want to see.
3 times 20, that's 60, right? 60 times 9, 540 is what I got, right? And then finally I got 9. No, that's not 9. That's 27.
So you got 27.
Woo, that would have been bad. All right, here we go.
It's right.
8,000. What?
It works.
Math!
Math!
Who knows?
Oh
Woo!
my god, it does work.
Of course it works. Oh, that's cool.
Wow.
We
Woo!
need to do this more.
Granted, it's a lot more work, but it works.
Wait, Mr. Munoz.
Yeah, but imagine it like 20, 30.
Math.
Hey, mister, so if you have like 11.
That's the thing. The Pascal's triangle, we can only use it for binomial expansion, which means it's two terms inside. Okay? If it's 100, now I technically have 3 terms. I have units, I have the tens, and I have the hundreds. Which one do you like?
That's really cool.
Yeah? Well, actually, here's the thing. Sorry. I knew that would work because I've done other properties with numbers, and they also work. For example,
So what do you have? Are you gonna like? What? What are you gonna do with this knowledge?
Nothing.
I'm just sharing it with you guys.
Yeah, I mean, that's
I was a little nervous because with the 8,000, but
Mr.
yeah, that's why I was like, why are you nervous?
How do you get 1, 3, 3, 1? I know from right there in that pyramid, but how do you know where to go?
well, you're making a triangle, so you always go with ones on the ends. So here's the way it works. 1 plus 1 makes the 2.
Yes, I get that.
You start with the 1, and then that gives you the 3. See that?
Yeah, I get that, but how do you know what number to go up to?
What's a degree?
3.
There's
Or you can think about it this way. This is 0, this is 1, that's 2, that's 3.
So if it was 4, you would go to the
I would go one more row.
Stop.
what else can this be applied to? What else can this be applied to?
Probabilities. The triangle?
Yeah, but so wait, does that mean there's a connection?
Stop it.
Then I'm just okay.
Stop.
Between 1, 11, 121, 1,351. Is there a connection between those numbers?
What are we talking about?
So if you look at your triangle,
Uh-huh.
if you just spread it across like a normal number, is there a connection between it? So like 1, 11.
Play with it. That's the fun now. See if there's a connection. That's what mathematicians do. That's how they try things.
Hey, Mr. Mooney, can I run it by you? Can I run this by you?
Yeah.
So I get it. You get the 3 from there, right? And the 20 from there. And 3. That's gonna equal 1, whatever. Blah, blah, blah. But then you get 20. Oh, hold on. I just had this too. Oh man.
Like that.
So, alright, I'm lost. 20. I know it's 20 times 20 times 20, right?
Right.
You get 8,000. Then from there, 36. 3,600. You're gonna get 3 times
20 times 20 times 3.
Right.
Yes,
Sort of. I'm still gonna be asking you a lot.
that's fine. Let me stop this real quick.
I have one theory. But what if you